For this example, we're going to find the volume of a prism. And this prism is created by having a triangular base in the xy plane. So the bounds in the xy plane are the x-axis, the line y equals x, the identity, as well as the line x equals 1. The top of this prism, this triangular prism, is created by the plane 3 minus x minus y. So this is up in space. This is a function of two variables. The output is z. Let's think about our region. And it's important for us to think about our region because it lets us know how to set up our bounds for integration. So we are in quadrant 1. So I have a bound, the x-axis. I've got a bound here, the x-axis. I have the line x equals 1, so we'll just call that 1. And I have some vertical line. And then the identity, y equals x. So this triangle is my region R. There's R. And this ordered pair here is 1, 1. Now, we have two options in order to help us set this up. We could set this up two ways. I'm going to write both of them out. So if we decided to integrate with respect to y first, we would have my bounds x, got x equals 0, x equals 1. So I've got x here, 0 and 1. So I'm traveling from 0 to 1. What are my upper and lower bounds? My upper bound is the line y equals x, and my lower bound is the line, the x-axis, y equals 0. So we would integrate this function, f of x, y, and we would say dy dx. So that is one setup. The other way we could set this up would be by thinking about these y values as constants. So we've got y equals 0 to y equals 1. So here's my y going from 0 to 1. My second integral, here, this blue line is x equals y. The further line away is x equals 1. So we would be going from 1 to y, left minus right, right? That's outer, inner, so higher, upper, and then lower. So we'll have x equals 1, x equals y. That would be f of x, y, and in this situation, we would say dx dy. All right, so either of these setups will work. The whole point of thinking about that region is thinking about how we can set these up. So I encourage you, pause, make sure that this makes sense. Notice that my bounds, up here I've got x equals 1, x equals 0, y equals x, y equals 0. Here I have y equals 1, y equals 0, x equals 1, x equals y. Okay? So everybody paused, everybody's caught back up with me. We're going to evaluate this integral. I'm going to plug my function in, which is 3 minus x minus y. I'm going to do it the way that I already have here on my screen, which is dy dx. And that's just conventional to go y to x. When we start talking about triple integrals and we have z, y, and x, or x, y, and z, we're always going to go z down to y down to x when we can. That's kind of the way we write the definition. So that's why I'm choosing this method. Okay, so integrating with respect to y, this is a constant, becomes 3y, negative xy, and negative y squared over 2. So I have x equals 0, x equals 1. And integrating that, I've got 3y minus xy minus 1/2 y squared. And my y values that I've got to plug in, I'm going to plug in y equals x, and then also y equals 0. And of course, I'll still have to integrate with respect to x. Now what's nice is when I plug in 0, all of those terms are going to go away. So I'm just going to plug in x. I've got 3x minus x squared minus 1/2 x squared. So I've got the integral from 0 to 1. I've got 3x minus x squared minus 1/2 x squared. -1 minus 1/2, that's -3/2 x squared. So we always have some algebraic simplification in there. I guess I don't need these square brackets anymore. So now we integrate with respect to x. That gives me 3/2 x squared minus 1/2 x cubed from 1 to 0. Plugging in zeros, again, going to eliminate both of those. So here I just need to plug in 1, which gives me 3/2 minus 1/2, or 2/2, which is 1. So the solution to the volume in this problem is 1. And I'm going to draw that region for us in 3 space to just kind of help us visualize what we just did. So I've got z, I have x and y. So our rectangular region, we had x equals 1 right here, or that ordered pair, an ordered triple would be 1, 0, 0. That's that point. We have our identity coming straight out here, giving me 1, 1, 0. I have a point at the origin. And so the plane is angled. That plane has a y-intercept up here of 3, 0, 0. So this is my plane z. I'm graphing z equals 3 minus x minus y. And so what it actually does is it comes over here to this point, 1, 0, 2. Also comes down to this point in space, which is sort of vertical from there, which is 1, 1, 1. So we have found the volume of this prism. So it's got a triangle on the top that's created by this plane. And then we have our triangular base here, which we were able to extrude up into 3 dimensions to create this volume. So the volume of that region is 1. Cool. There's a picture in your book too, but I wanted you guys to see how I was drawing it. All right. Good luck in the real world. Just kidding. You can email me whenever you need help. It's starting to get old the way I always say that. I don't even know anymore. I make so many videos all day. But my dad always says that to me. Good luck out there in the real world. Or he also says, be safe and have fun. So that's what I'm saying to you guys. I digress. Good luck.